Welcome everyone to Dragon Con Goes Virtual. My name is Liz. I will be moderating one of Science Track panels this year. Can you yeet it for science? So before we get going, I'm going to let all of our wonderful panelists introduce themselves, starting with Divya.
All right, thanks Liz. I'm SB Divya. This is my first time at Dragon Con. I'm very excited to be here, albeit virtually. I am an author of science fiction and fantasy. I have 2 books to my name, Runtime, which came out a few years ago, and Machinehood, which will be out March of 2021. I'm also the co-editor at Escape Pod, a weekly science fiction podcast magazine. And by day or previous profession, I am an engineer with a background in computational neuroscience, machine learning, and signal processing.
Thank you. And next is Jen, who I will not let escape. Just recently defended her thesis. Congratulations again.
Thanks, Liz. Hi, I'm Jennifer. As of July 13th, Dr. Jennifer Greco, definitely not used to that yet. I am an astronomer. I am currently in transition. I've been in Ohio and I'm now moving to Sweden. My wheelhouse is near infrared spectroscopy of low mass stars, although I'm going to be switching to studying the atmospheres of extrasolar planets in my future postdoc work. So I'm pretty excited about that.
Okay, and Nicole?
Hi everyone, Dr. Nicole Gugliucci. I am physics professor and radio astronomer and education researcher now. I don't know, I do lots of things that interest me. So yeah, I'm just excited to be here. I'm missing the in-person experience, but excited we're doing this.
And last of our panelists, Joe.
Hey everybody, this is Dr. Joseph Meany here, postdoctoral research associate at Savannah River National Lab and residential chemist. I also happen to be an author with 2 contributions to my name. I'm co-author of Graphene, a popular science novel about the carbon-based material, and I'm also a contributor to the Stellaris anthology, a science fiction anthology put out by Baen Books.
Thank you all for coming today. So I think without further ado, let's start discussing things that you can and hopefully might be interested in eating. Okay, I believe you can all see my PowerPoint screen now. So just to remind everyone, the definition of yeet that we are working with today is to throw something with a lot of force. This is taken from the Cambridge Dictionary. So it can be flinging, it can be throwing, it can be shoving. Just sort of any means of ridding yourself of something you may not want in your life anymore, or shoving something towards someone else who may want that thing. So we're going to start out with Divya. What item would you like to yeet?
All right, so one thing that I wish I had a chance to yeet in my career is laser beams out into space for NASA's Deep Space Network. I spent a lot of time in high-speed communications, yeeting straight electromagnetic waves and electric pulses through wires for Ethernet, for DSL, but deep space communications, I think, would be an awesome application for a lot of the things I like to science, and something that I think we are needing more and more of as we start populating our solar system with robots.
So do any of the rest of our panelists have some opinions on yeeting signals out into space, whether that's going to be difficult or challenging, or whether it's a good idea or a bad idea from thinking about who we might encounter?
I'm definitely like staring at this, trying to figure out exactly which radio telescope this is, because it's not a very large array dish. But it's not clicking what one this is. This is probably just receiving. But my favorite thing that yeets signals into space would definitely be the Arecibo radar and radio observatory. They've been doing that. They tend to yeet. They'll yeet signals. I feel like such a poser because I'm like, what is yeeting? They yeet signals at asteroids to map them with radar. So that, I think, is my favorite, which this reminds me of.
Jen, you look like you have something to say.
I was just glad I wasn't the only one trying to figure out what telescope that was. You said that and I was looking at it going, I know, right? I wish I knew which one that is. I don't know. I've just always, in the sense of yeeting signals into space, wondered, in terms of like trying to communicate, like, if someone's looking at the Earth, how can they tell what kind of signal they're seeing, and how could we get them to go far enough? And I think that's a thing. And just in terms of like future science, I think would be cool if we developed like creating radio signals that could like really go that far and still be understandable is like one of the things I'm most excited about trying to see if we can do.
So just to clarify, I pulled this image off of Wikipedia on one of the pages about sending out deep space signals. It's an artist's rendition of, unfortunately, I don't actually know if it's anything specific. So my apologies on that. That's my bad. I didn't mean to vex the
this is a generic
Astro folks in here.
This is a generic dish, so it's fine.
Joe, did you have something you wanted to add?
Well, I actually wanted to ask Nicole if she happened to know if there's any plan to fix the Arecibo. I know that it suffered some kind of big accident recently, and I wasn't, I don't know the current status of it.
Yeah, I am not super in the know on that. In fact, that's why it's been on my mind lately. A cable snapped and damaged a section of dish. A lot of the first images that came out made it look, just the angle it was at, it looked terrible. Later images showed it was just a small portion of the dish. So I think they're still working on figuring out how much it would cost to shore that up, especially since it's hurricane season. Yeah, it's definitely a unique instrument. So I hope that they are able to shore it up for now and then fix it up as soon as they can.
I think with a lot of the interesting advances that are being made in optics these days, if we have time, I'll get to talk about it a little bit, but being able to create really strong, really coherent beams, the material science behind that is not a simple challenge to overcome in and of itself. So we're going to learn a lot of really interesting chemistry. We're going to learn a lot of really interesting physics, just trying to be able to get to producing those kinds of signals strong enough to reach interstellar. I'm really excited to see where that starts to go.
If we do light pollution, if we do lasers interstellar, are we going to generate light pollution for our alien friends far in the distance, right? Because we're now creating interference by emitting light from a dark body, which is our planet, right? Which we're somewhat reflective, but we're not an emitter of light. Is that going to be confusing? Or tying into the METI thing, which is, messages for extraterrestrial intelligence, is that a way to advertise our presence to the rest of the universe? Like, might it be a good thing to yeet some light out there from a non-star?
I can say something about light pollution. I feel like a laser beam is not going to be a big source of light pollution. Most of the light pollution you worry about is the stuff that's close to your observing position. It depends. I don't know. What do these particular alien beings, like, how do they do their astronomy? How much do they care about hearing from other intelligent civilizations? Are they, I don't think it would be a big deal if they were, like us, just to get that pinpoint of light. I think that would be super exciting and not too much of an interference.
So continuing down or around the table of yeetables, Jen, would you like to suggest something to yeet?
Sure. So I am an observer, which means I spent all of my thesis work looking at things through telescopes, in particular, very faint things. And I've had a lot of observing time on nights when the moon was very bright. And when the moon is brighter than your target, you can see nothing. So many, many times I have wanted to yeet the moon, just like right out of my way, just like if you go away, my star will be bright. I'll get beautiful data. It'll be wonderful. So I did a little back of the envelope math this afternoon on yeeting the moon because that sounded like a really fun thing to do. And I learned that to get the moon up to a required escape velocity, it would take about 7.6 times 10 to the 30 joules of energy, which is a very large number. And so to try and put that into context, I looked up that the world energy consumption is only about a third of that amount. No, it's 10 to the 20 joules. So not even a third of that. I can't do math in my head right now, is much less than that. And in order to generate that much energy, you'd need about 100 quadrillion Saturn V rockets. So I'm struggling a little bit because as much as I would like to yeet the moon, I don't have that many rockets. And also you would need to get the rockets to the moon, which would require more rockets. And so I'm struggling a little bit because it would require 7.5 times the mass of the moon in rocket fuel, which is very heavy. So I don't know if anyone has any ideas on other ways to do this.
Are you looking to get rid of it immediately, or are you okay giving it enough of a nudge that astronomers 3 generations from now don't have to worry about it? Because I feel like that's more doable.
It would be more doable. I mean, I have my thesis data now, so I guess we could do a nod to the future me in a few generations. So that would certainly be an option. Yeah.
So what if we? This is a I think almost trope at this point in science fiction. But what if we used explosives to blow up chunks off the moon, preferably away from the Earth, and start gradually whittling away at it, reduce its mass? This is a little bit of an overtime unless we can explode the whole thing, but I suspect that would take an equivalent amount of energy to blow up the entire moon. Also not really good for the Earth to have all that moon rock flying at us. But yeah, maybe we could just, slim it down a bit so that when the day comes that it's small enough, we can then eat it more quickly. I don't know which method would be faster overall.
I don't either, but I like your idea of combining the methods. Like you blow some pieces off and then you have like some small moons and then you just like yeet the small moons. I don't know if this is a potential strategy we could go with.
Well, here's a question. If we turned the moon into dust and Earth had rings, would that be better or worse for astronomers?
I feel like that would suck for satellites, depending on how far out they were.
Yeah, forget the commercial stuff, but like for you, for the science and the astronomy, is that going to be better or worse?
I think it depends on what you're looking at is, right? Because like here's the Earth, here's the rings. And so like if what I'm looking at, like if the rings are between me and what I'm trying to look at, it would probably be worse. But if I was looking at something like straight up and the rings weren't there, it would probably be awesome. I don't know if Nicole has any other thoughts on.
So the position of the rings matters, right? You don't want it to be across the same, such that you don't want it such that the sky is rotating the same stuff through the ring all the time.
Yes. That is true.
Joe, did you want to chime in on this issue of yeeting or exploding the moon in various ways?
Yeah, I'm trying to think, wouldn't the orbital momentum of most of the rest of the moon keep the rings pretty well in the ecliptic? Or is there kind of enough of the energy from the explosions that we would be sending these rocks in non-ecliptic orbits? I don't know. Well,
if it was at the moon's orbital plane, it's 5 degrees to the ecliptic, but it's still, I could just see, astronomers, man, I could just see someone's going to have a problem with it. Someone's going to have their favorite object that's behind it most of the time if it's close to the ecliptic.
Yeah, I feel like instead of being a very concentrated problem, it becomes a very diffuse problem. So it becomes a minor problem for everybody or a lot of people rather than a very major problem for fewer people.
Yeah, I would agree with that, I think.
But the moon's a big deal for optical astronomers, as I understand.
So I have an alternative to yeeting, though I suppose this panel is technically about yeeting, but let me try to frame it as a yeeting problem. Are you all familiar with Vantablack? I guess I should assume that the audience is not necessarily. So Vantablack is a black paint that we've developed. Yeah, that's right. You probably are and can talk about it much more. But the TLDR version is, it is highly non-reflective black paint. So maybe we could yeet enough black paint all over the moon. This is terrible for the moon's ecology, but it stops being this bright, white, dusty thing and instead becomes like just a dark hole that, you know, at least you can see around it better in terms of optical astronomy.
Okay, now maybe I need to do the calculation about how much carbon that would actually take. So to fill in a little bit of what Divya was talking about, Vantablack, Vanta actually stands, it's an acronym, and so it stands for vertically aligned nanotube arrays. And so you have this two-dimensional surface where little spikes of carbon are standing on top of one another, these little nanotubules. And because of the way that the light comes in and interacts with the carbon atoms, the energy is absorbed and dissipated almost completely within this surface. So you're yeeting any light, any possibility for the light to get back out. And we're getting very, very close to almost complete light absorption. I think there's probably 99.999% of light absorbed by a Vanta surface. And each generation of these devices is just adding another 9 onto that array. So it's really useful when you want to put it inside telescopes, spectroscopes, anything that might have stray light where you don't want it to be, and it just gobbles that light right up.
So we've figured out, hopefully, ways of making the moon less inconvenient for our observational astro friends. Let's get another yeetable. Nicole.
Sure. I would like to talk about how black holes yeet stuff. Just actually finished up, literally finished a summer course on Tuesday, started the fall course on Wednesday, both on astronomy, and we ended, one of the near end topics was black holes. And so my students were telling me, you know, this is definitely there, you know, when they learned about black holes, you know, when they first heard of it, they thought, wow, it's like a vacuum. It sucks everything in. And we learned, no, they don't suck. They pull through gravity. And it's not that bad unless you're close. And one of the things that really amazed folks was, you know, how do you see a black hole if the light can't escape? Well, you have lots of stuff happening outside the black hole. So this is an image from the Carl Jansky Very Large Array in New Mexico. This is a close-up of a, well, sort of close-up of a supermassive black hole in the center of a powerful radio galaxy called Cygnus A. This is one of the brightest radio sources in the sky. Used this as a calibrator for our tiny little antennas in grad school. You could see it, it's just blazing. And it's got these huge, these long jets that go outside of the optical visual part of the galaxy, these plumes of gas. But this is zooming in on the center. There is a torus of material that is orbiting this black hole. And this black hole is active, means there's stuff actively being pulled onto it. But not everything can get pulled onto it all at once through some mechanism that we don't entirely understand still. Some of this stuff gets shot off in jets, bipolar jets, so one in each direction, near the speed of light. So these blobs, and I have literally called them blobs in scientific journal articles, these blobs of particles basically yeet away from the black hole, far off, sometimes out of the galaxy. So this is one of my favorite things because it's so weird and so cool, and it is the opposite of what you think a black hole should be doing. Usually you think a black hole would be gobbling everything up and not yeeting stuff into space.
I actually had a question about the yeeting process. So is this a net yeeting? Is this black hole getting smaller or bigger?
No, it's getting bigger. So some of the material's still going onto the black hole, accreting onto the black hole. Accretion is just the word we use. But not all of it makes it. We see the same thing in young stars when they're forming. So they're pulling themselves together gravitationally, but not everything gets there. There's some turbulence there that shoots some of the material out. The star's still growing, the star's still adding material, but some extra material doesn't make it. It ends up in this jet flow that goes away from the object.
And are the two jet flows equal, or does this thing having a net movement from that yeet? Is it yeeting itself?
It should be equal to it. So yeah, it should be, I think it should be equal. We don't always see them equally because there's this fun effect called relativistic beaming, where the stuff coming towards us is brighter than the stuff going away. So it's a lot easier to see the stuff that's coming towards us, which is why I think the right side here is a lot brighter than the left side. But that is a weird fact of special relativity, which hopefully we'll get to talk about a little bit, that makes one side look brighter.
I had another question as well, because black holes are a little outside my wheelhouse. You mentioned that they go out of the galaxy. Do we have any idea, like, how far these things travel after they get yeeted off the black hole?
I want to say, you know what, I'm gonna mess it up if I give it a number. Cygnus, I feel like I was going to say parsecs, thousands of light years, definitely. I don't know. I think I would say maybe up to a million parsecs. Sorry, up to a million light years. I could be wrong there, but Cygnus A is one of the huge ones. Yeah, definitely outside the visible disk or ellipse of the stars of the galaxy.
I love science. That is so cool.
I may be wrong on the millions thing, but they're big.
Going back briefly to yeeting the moon, ignoring the impracticalities of moving a black hole around, if I lined one of these up, would I be able to use the jet to yeet the moon, or would it just destroy the moon, you know, as per our type 2 moon removal process?
I wonder if the density of the blobs, which is basically electrons and positrons, would be enough to move the moon, or if it's, because we're talking about huge size scales here, that the density is such that it would just kind of drift through and not do a whole lot.
Fair enough.
I mean, could we line this up such that the moon just goes into the black hole and that solves all of our problems right there?
We could yeet anything. We should just yeet everything into a black hole. Forget yeeting it into the sun. Black hole is the way to go. Best trash compactor ever.
Very compact. So moving on to a slightly different area of expertise. Joe, would you like to tell us about one of your yeetables? Picking on you just because you're just finished a sip of water.
Oh yeah, well that means at least my my throat is fresh. So yeah, I wouldn't necessarily call the first one that I'm choosing my particular area of expertise, but it goes back to an entire childhood fascination, and it's a snake that can yeet itself. And I know that people find snakes themselves a little bit disconcerting. Indiana Jones himself had a bit of a problem with it. But this snake is special in that it can launch itself from treetops and can glide along by wiggling itself back and forth. And just up until this summer, the mechanism for how the snake itself could fly was a complete mystery. So this is brand new science, just got published in Nature, I think last month. And just understanding what is going on here has huge implications for not only animal movement and understanding aerodynamics, but it's also got some applications in robotics as well. If you could imagine smart snake-like robots that just start to slither and take off. So what's going on here, I have a picture at the top where the scientists took one of these actual snakes and built a massive fake tree in a 4-story black theater, right? And then they took these little paint chips and put them on the snake so that they could track the motion of the snake as it launched itself from the fake tree, and use all of these cameras similar to the ones that they use for motion capture in movies. And they figured out in 3 dimensions how the snake is actually moving to keep itself stable. So what was really interesting is when they had captured all of this data, they said, okay, if the snake is just moving back and forth in a single plane, what happens? Well, the computer model that they built from that, the snake tumbles. So the back and forth motion isn't enough to keep the snake stable. What is actually happening is the snake is moving back and forth, up and around. And it's this up and around slight movement that keeps the snake upright so that it can come in like a plane gliding onto a runway. And so this snake can move several tens of yards from the top of the tree horizontally to the ground to launch itself away from predators that are trying to eat it. I mean, the snake is kind of small. It's only a couple of feet long. So it's actually quite cute if you see it, and it's got quite nice little orange colors there. I love the banding on it. But so it's flat, it's wide, and then it just moves back and forth and up and down as it's in the air. And I think that's just an absolutely fascinating use of muscle control to keep oneself upright in the air. And it's completely unique as far as snakes are concerned. This is a Southeast Asian paradise tree snake is what it's called.
So it's effectively self-eating. Sorry, Nicole.
I was going to ask, how can I use this for a prank? Or is that just too mean to the snake? I don't care about being mean to a person. Is that too mean to the snake?
I was going to say, we have some pretty sizable trees in New Hampshire, right? Like, so, you know, I don't think you would have to do this during the summer in New Hampshire. This is definitely not a fall kind of thing. But yeah, you might want to consider that might not be the best thing for the snake, as long as you treat it to lots of tasty snacks afterwards.
I was wondering if we could use the snake's some biomimetic properties to become the next base jumping trend, right? We have the flying squirrel suits based on the gliding squirrels. Can we have some sort of snake-like interface for a human being to be able to eat themselves off a cliff and not break anything or kill themselves?
I think that would be interesting. And you would have something like, I guess, an articulated mermaid tail. And so the person would have to know enough that they'd have to move their upper body up and around. And then the articulation of the tail could take care of the side to side motion. It would definitely make parajumping and that sort of stuff. Definitely a whole new level. Absolutely.
I'm now like trying to work this out. Like, how would someone in a snake suit have to move to get all the dimensions of movement you talked about? I was wondering, you mentioned something about like flying snake-shaped robots, and I'm curious about, like, could we make a small snake-shaped robot that would be able to move like that and maybe fly?
Oh, sure. And the authors of the paper actually talked about that as a strong application for this particular research. So they're really interested that if you have a small enough, light enough, and segmented enough robot that's moving each of its joints independently, it could self-correct. And if you have a strong enough battery and a strong enough propulsion method, it might be able to take off, not just jump with style a la Buzz Lightyear.
That is really cool.
Yeah, I was thinking about our current quadcopter drone construction, which is not terribly aerodynamic, right? It requires a lot of power and a lot of control dynamics to keep them stable and going. You could potentially have far more efficient drones that are snake-shaped, that use less energy overall.
Yeah, because if you say distribute the mass of this snake robot over a large enough area using things like lightweight polyimide plastics or something of that nature, that you can create a large flat surface area with really low density, then you're starting to talk about, okay, it can create just enough of its own lift that it'll maybe be able to steer itself on these semi-passive air currents. And so that would be really interesting to start exploring, especially for those people that are developing lightweight materials.
Now I'm jumping ahead to thinking about dragons, but a lot of dragons, you know, there's the lizard-like dinosaurs with wings style of dragons, but there's the snake-like dragons where you could have very lightweight wings, and if they're very small, right, and like Joe was saying, very low density, low mass, like they should be able to, there we go. That one is maybe a bit more massive than one, maybe like tiny dragons. But tight with like little snake-like bodies and very thin sort of gossamer wings could be pretty easy to construct as a little robotic device. And obviously my mind goes to spy devices, but I'm sure we could use them for science too.
I think cute little pets.
Yeah, and we were talking a little bit in the preparation for this about weather monitoring. And so like, what would a distributed network of these passive flyers that maybe have their own directed antennas on them, that they could coordinate this swarm, for lack of a better term, I guess, that would be able to, in real time, track and transmit data that might better improve our weather models. I mean, right now we've got 2 hurricanes bearing down on the American Southeast. So it's those sorts of things that if we can get better information to people faster, they can make better informed decisions to protect themselves. So I think there's a really good use case scenario there, especially if they're able to flit around in areas of the atmosphere that are maybe a little bit less prone to high turbulence.
I'm actually wondering if the reticulated nature or articulated nature of the snake body would make it more resilient to high turbulent situations, because unlike a rigid glider like the weather planes we often send into storms, right, which are gonna have a lot more, you know, torsion and stress, if you have a body that can flex and curve in flight, it might actually do better in terms of navigating turbulence, especially rotational turbulence like you get inside storm cells.
Yeah, that's a really good point. And if they were built with the machine learning or AI, that they have, the gyroscopic detection and could sort of self-stabilize after these turbulent events, that I would have to talk to an aerodynamics expert, but that seems kind of plausible to me.
As fascinating as this is, I do want to give us a chance to go through more of the Yeetables. So I'm going to pass it off to Divya to suggest another object to yeet.
All right, so I'm going to go back to my old favorite, which is not a new idea, but it's not one that we've implemented yet, I think for various practical constraints. Yep, that's one. Where way back in 8th grade science, one of the things my first choice for a science project, which was vetoed because it was impractical, was how to set up a system to yeet nuclear waste into the sun. Because we don't want it on the Earth, we can bury it, but we know that it's always potentially problematic. It seems like nuclear waste into the giant nuclear furnace is a logical solution. And I'm aware of some of the current engineering challenges, the biggest one being getting it off the Earth. But let's assume that we have some magical, space elevator technology or something to get it off the Earth. How do we yeet it reliably into the sun?
Or into a black hole, if people have ideas on that subject.
I can think of, there are lots of comets that yeet themselves into the sun. So you'd probably want to maybe approximate one of those trajectories. There are lots of little planets they've seen from studying the sun that just all the time. It's the biggest gravitational well in the system.
I mean, I'm no propulsion expert, but is there any way that we could use the waste itself once it's out of the Earth's gravity well as the propellant to send it toward the sun?
That would be I feel like we're treading on nuclear test ban treaty territory, which is why we don't have, nuclear powered spaceships in the first place. Other than it's hard and expensive. But yeah, at a certain distance. Oh.
Could you use the radiation to push against a kind of sail? Something lightweight, some reactive material that it could at least use as maybe not as a continuous propellant, so you're not leaving a trail of nuclear waste behind you, but just as sort of an initial impulse to get away from the Earth and kind of get into its final death spiral trajectory. That sounds so sad. I feel bad for nuclear waste, but we want it to be in a death spiral trajectory. So I don't know. Yeah, that's one I don't know enough about.
So I was basically thinking that this rocket, for lack of a better term, would be a little bit more of akin to a fission engine, where out the back would be coming helium, nuclei, and electrons. So alpha and beta emissions, more so than the heavy atom nuclei from the nuclear waste themselves. I suppose we would have to bring in a fission engine expert to talk about that a little bit more, but I bet you they're over on the space track.
I would say you have to invent that entire technology. We haven't, other than bombs, we don't know how to control fission.
Would we be okay temporarily storing it on the moon if we could get there?
No, we're going to destroy the moon, you see.
We'll be putting on the moon, and then we yeet the moon into a black hole. Therefore, we get the nuclear waste straight into the black hole.
I like
there
it.
You go.
One deal.
I feel like this is a planetary ecological disaster that we're planning here. I mean, it's fun. It's fine theoretically. Just saying.
What could possibly go wrong?
I know, right?
Well, ignoring how we get the waste there? And ignoring, okay, a single barrel, 2 barrels, is there any quantity of nuclear waste that we could yeet into the sun that would begin to cause the sun itself any problems? Or is that there's just not enough on the planet?
I can't imagine there's enough on the planet. It would make, I imagine it might make some cool new spectral lines show up in the solar spectrum. But stars, stars eat entire planets, and you can barely tell except for extra spectral lines in its spectrum.
Mm-hmm. That's something I was wondering about, though, is if we yeet enough nuclear waste into the sun and we change its spectrum, and like aliens in another solar system are looking at the sun's spectrum, like, could they tell this was an inhabited star system by realizing we'd changed the spectral lines of the sun? And is this then a solution to our first topic of yeeting alien signals into space so that other civilizations can find us?
Passive METI, interesting.
It's a very, it's like a very niche SETI topic, right? We can search through spectra for stuff that shouldn't happen.
How accurate are our solar spectra right now in terms of signal to noise ratio? Like, would we be able to it sounds like we can we detect, can we see the difference when another star outside our system absorbs one of its planets? Like, do we know that for sure?
I had a friend who worked on that in grad school, which is why it came to mind. As far as I'm not an optical anything, but I feel like the solar spectrum, we have super high resolution. What you need is for the material itself to also go through the right transitions to absorb the right light. So, I don't know how useful these really super heavy atoms would be at that. I guess it depends on what you pad them in. If you pad it in a lot of calcium, you'd see that.
Oh,
how much calcium is in the moon?
I imagine that the emission lines from heavy atom elements are pretty bright.
But this would be absorption, though. This is absorption.
Oh! I was thinking atomic emission spectrum from the sun. Okay. They have lots of them because there are lots of orbitals for the electrons to jump around in. But how that compares to the background of all the other stuff that's going on in the sun, I can't really say with much accuracy.
I think that's a question for a qualifying exam for a future astronomy grad student.
The one in a few generations by which we will have slowly moved the moon. I think another side of this as well is how far is the alien civilization, like how far away are they? Because of course, the closer they are to us, the easier it's gonna be for them to see. And if they're far enough away, they're not gonna have a high enough signal noise to see much of any of that, I don't think.
Do you know how far away an alien civilization could even reasonably see our star from?
And get good spectra?
Yeah.
Do they have their own version of the Gaia spacecraft, which is currently taking spectra and brightness of, what is it, like 1 million stars?
I think, are we at 1 billion now?
I think, no, they're heading for 1 billion, yeah.
They're headed that way, yeah.
I don't know if they're going to get spectra of 1 billion, but definitely like parallaxes and brightnesses.
Yeah.
So, yes, if they have a Gaia spacecraft, which is a very lovely spacecraft, then sure, I think you'd see out, oh gosh, I was just asking somebody about how far out we could get parallax for that, but I don't know about the spectra. I mean,
I'm not familiar with that spacecraft. What is it?
So Gaia is not an acronym for a spacecraft for once. European, I think it's primarily European Space Agency, is getting brightness and position, and I think in some cases spectra of up to 1 billion stars so that they can get parallaxes, so direct geometrical measurements of distance to a much larger sphere of stars around us than we currently have. Yeah, so I've been looking at that because I do a little bit of optical sometimes. They've been able to look at some double star pairs. So two stars that are near each other that take decades potentially to go around, decades or centuries to move around each other. From our, our ground-based telescopes have been looking at them, but the Gaia measurements of these double stars are super precise. So it's adding on to what we're already doing with small telescopes around the globe.
So let's try to do a few lightning rounds before we run out of time for the panel. So Jen, give us a yeetable.
I mean, we already sort of did a preview of the dragon one, so we'll jump on that. This came out of a conversation that I was having with someone the other day about what it would be like to yeet things that can already fly. And so we were thinking, like, what if you yeet a flying broomstick and, like, once it starts flying, then, like, could it just go an indefinite distance before it stops flying? Or in terms of a dragon, like, does the fact that it has wings help you in the sense that, like, if you can get it going, which depending on the size and weight of your dragon might be very challenging, like, then can you just have it glide a really long distance? And would it then go farther than that object would without wings? And so I thought this might be an interesting thing to discuss and see what people thought of yeeting magical objects, or I guess non-magical objects that can already fly, and what that might look like.
I think eating a magical broom, a non-living magical object, is going to have different rules. And therefore, something like that could go very, very far because it's got propulsion systems that are pretty powerful. Whereas eating a dragon is not that different from eating a large bird, where if you eat it too hard, you're going to hurt the bird. So you kind of have to work with the bird's biology to a point. So you might be able to give it a bit of a boost, but at some point it's going to start flapping its wings, and like normal physics and aerodynamics will just take over, and it's going to probably slow down to whatever it can fly at. So that's.
I'm just wondering why you're eating the poor dragon. Like, does it have a bad leg? Could it not take off on its own? What's going on here?
That would certainly be an application. Like, if it needs a boost into the air, like it has trouble taking off because it's like, there's not enough space for it to flap its wings or whatever. You just kind of like boost it into the air and then it can glide.
Like the snakes.
That was one thought that I had. What?
Like the snakes, which we discussed earlier, which, do gliding rather than flying. Joe, did you have any commentary you wanted to add?
Will the dragon fit in a trebuchet?
How big is your trebuchet?
How big a tree can you
get? The size of your
get?
dragon and the size of your trebuchet?
With modern materials, could you make a trebuchet strong enough to yeet a dragon the size of Smog?
Ooh, I would want to do that calculation, because I think with some special carbon fiber embedded materials and some of the advanced thermoplastics and thermosets that are coming out onto the market these days, if you get the right system, you could probably 3D print a trebuchet big enough to yeet a dragon.
That would be a very big 3D printer.
Yes.
Continuing in the lightning round, Nicole.
Hi, we're playing with our toys in the background. Lightning round, I want to talk about meteors because we just had a really pretty meteor shower. This was another one that I got to experience a little bit through my students' eyes, brains, whatever. I have them do virtual observing events because we can't all gather at the telescope when we're learning online. So they went to a virtual star party about the Perseids and learned all about meteors and shooting stars, which again, due to the misnomer shooting star, a lot of them thought was an actual stellar phenomenon. But instead you have meteors are these tiny, like pebble size to like sand grain size of space junk that makes its way into the atmosphere. And as it comes through the atmosphere, it heats up the atmosphere that it's going through so much that it ionizes the air around it. And that ionization and then the recapturing of those electrons is what's making that super, super bright streak that you see going through there. You can see meteors on any clear night if you just watch long enough. But for meteor showers like the Perseids, which we had recently here in August, you could have up to, I think it was something like 50 to 75 an hour. So quite pretty.
If we went with yeeting the moon plan 2 and blew it up, does that mean we'd have a fantastic meteor shower?
Until we all die, yes. Yes.
And it'd be like the Endor Armageddon a little bit, right?
Yeah, yeah.
Oh no. Reasons to not eat moon-like objects.
That's why you have to eat them
away.
away.
Fantastic. Yeah, it would be a fantastic meteor shower, or we would turn out like the dinosaurs, right?
Divya, did you have anything you wanted to add on the yeeting meteors or yeeting small objects through the upper atmosphere?
Yes, I have a yeetable for the upper atmosphere, though it's not meteors. So I guess I'll steal from that, which is to yeet defunct satellites and other space junk of our own manufacture back down to Earth in a safe manner that will hopefully not kill anyone. And yeah, and basically, you know, how do we deorbit and yeet satellites and other space junk so that it gets down here and it doesn't take out our other satellites in the process. That is definitely a thing that we all are trying to yeet and need to yeet more. There's a laser-based solution, which I thought was pretty hilarious. Even though some people are talking about it as a legit way to try to basically burn up and break up the satellites before they come down. Because one of the big problems is some of our satellites are pretty large, right? So it's ideal if, much like with the moon and other meteors, we can break it up into smaller chunks that are more likely to burn up in the upper atmosphere rather than having to wait for it to like deorbit and splash down. If it doesn't splash down somewhere safe and unpopulated and instead crashes into, you know, a skyscraper, that would be a very high velocity projectile weapon at that point.
Joe, I think you had some strong opinions on this subject in the pre-discussion.
Oh yeah, I mean, there's some interesting things that are going on in private industry. I know there's a project called the Braincraft that is going on that works towards deorbiting some of the decommissioned satellites. And I don't know the status of the project at the moment, but at least last time it was working, the project effectively had a craft that was just a very large flat panel that was super flexible. And so it could act as a catcher's mitt to wrap around a satellite that would then, under its own power, just slightly alter the orbit of that craft and put it on a downward trajectory to burn up in the upper atmosphere, which I think is a really interesting solution. You know, we need to do the same sort of thing for planetary protection purposes. And I would gladly turn the floor over to the colleagues on the panel to talk a little bit more about the Cassini.
I just shrugged and went, I know it was yeeted into the planet, but I don't know much. I honestly don't remember much else about that, except that we were all very sad.
I remember I was at a talk someone gave about Cassini before they did this, and they were like, we really want to shoot it between the planet and the rings, but it might kill the spacecraft. So this person was explaining this crazy idea NASA had where they were going to shoot it on this like crazy angle between the planet and the rings and take data on this super cool angle right before they yeeted it into the planet to kill it, because they figured if it accidentally blows up the spacecraft, we were going to kill the spacecraft anyway. And I thought that was really awesome. And it was a cool thing that they were going to do. And I don't know if it worked or not. I haven't had the opportunity to check, but they had all these plans of crazy observations they were going to try to take on their way to killing the spacecraft. Because basically they decommissioned Cassini by chucking it into Saturn and letting Saturn destroy it for them.
Why did we yeet it into Saturn?
So yeah, we as we've spent the last hour polluting the entire solar system, we do actually try not to pollute the solar system in reality. I guess the fear is that one of these probes could land on, say, one of the moons. I know this was a big deal out, for the Jupiter's Galileo spacecraft too. And potentially some microbe that somehow survived all that time could contaminate an otherwise pristine environment. So even with, one little spacecraft around a gas giant, we may toss that into the planet, so we're not contaminating any pristine environment.
So one last eatable from Joe.
Oh yeah, so I'll try to make this super quick. We've been talking about yeeting a lot of big things here during this panel, so I thought I'd turn it around and yeet something a little bit smaller, like Stonehenge. No, not really. We're not going to yeet Stonehenge. That would be a really bad idea. But there was some interesting science that came out of the UK recently, where some scientists used a method called mass spectrometry to yeet atoms and figure out that Stonehenge actually came from a different place than they originally thought it came from. And it turns out that when you bombard the atoms that make up the rock, there is a particular fingerprint that you can use to separate out these atoms by their mass to charge ratio using what is called a quadrupole magnet. And this quadrupole magnet, there are 4 poles that allow the atoms to move in a semi-straight line. It's kind of an oscillating trajectory. I guess I'm talking about a lot of oscillating trajectories today. And it allows each of the atoms to separate out, and you can tell exactly what is making up the rock in the Stonehenge. And they found out that the makeup differed from where they thought the rock originally came from, and actually matched it to a new area called Westwoods, about 15 miles from where Stonehenge is actually assembled. So there's still a lot of mysteries surrounding Stonehenge, but people are making a lot more effort at finding exactly where it came from, and they're hoping that the next steps are to figure out the exact quarry where the rocks originally came from. So we're sniffing around for a lot of atomic clues here inside archaeology, and this is getting us just a little bit closer to solving a mystery where nobody can actually tell us the story face to face until we invent time travel.
So is the thought on this that the rocks came from somewhere 15 miles away and were moved there? Is that what they're thinking, or?
Yeah, so the original idea is that the rocks came from a place much further away in Wales. But this, because there are rocks of the similar strata that have been found in this original location. But they found that when you put these atomic fingerprints side by side, they don't actually match up to this original area, and instead it matches better to the atoms found in this new area. And so you fire either very fast atoms or very powerful lasers at these rocks, and it heats up the rocks so that you get these atoms and molecules flying off of the surface of this sample. And you can characterize these cross sections that are taken from the rock itself to be able to match up these identities. And so that you would yeet them down a long tube inside a vacuum, and it's these quadrupoles that separate the atoms out by their residual charge. And you can say, aha, we have 35 silicon atoms over here, and oh, we've got some fluoride over here, and aha, we've got a little bit of calcium, but the calcium doesn't match to this old place, but it does match to this new place. And that's kind of what they're finding out with this rock mass spectral database.
Seems like it would be a really, really useful tool for planetary geologists to kind of track the movement of rock over time and layers of rock and kind of match things up.
Yeah, and because it's a quantitative method, you're not necessarily working off of piecing all these individual clues together to come out with a grander picture. You're actually able to say the rocks from this area of the plate tectonics moved in such and such a direction at such and such a rate over these millions of years. And while I'm no geologist, I think it could be interesting to even think of the individual plates as somewhat malleable. Maybe we should bring in Mika to talk to us a little bit about this, because I'm not up to date on my planetary geology. But I think it's an interesting idea to at least consider.
Well, I think that's unfortunately all we have time for in this round of Can You Yeet It for Science. Thank you all for coming and speaking today. I would like to go through the panelists one more time and give them a chance to let you know where you can find them online, where you can find the things that they've worked on, or anything else they would like to share. So going again in alphabetical order, and the closeout, Divya?
Sure. You can find me online on Twitter as @Divya'sTweets, or you can look up my website, sbdivya.com, fairly straightforward. You can find a lot of my short stories published in various magazines online that are freely available to read. You can find my books on pretty much wherever books are sold. And as for my technical work, right now I'm working on AI for a sleep tracking app called Sleepwatch for Apple Watch and Apple products. So if that's something that interests you, go check it out. Thank you.
Jen?
I'm in the process of moving, so probably the best place to find me is going to be on Twitter @AstroGrecoJ, because I'm sort of in between two different postings right now.
Nicole?
Hi, you can find me online as Noisy Astronomer. Other than that, I'm still doing tenure track things. So yeah, just ping me Noisy Astronomer on Twitter, Instagram, all the socials.
You can find me on Twitter and most of the major social medias. I'm @Crimson Alchemist. That's ALKEMIST. You can find my books here at all the major booksellers, although I do recommend you go to your local neighborhood bookseller to find them and give them your business as well. You can also find me in much of my other work with the Interstellar Research Group at irg.space. There I sit on the board of directors, and we're doing some really interesting stuff coming up in 2021. So go ahead and check us out.
And if any of y'all want to find me, you can find me on Twitter @Telekahath, or that might be reversed, in which case that's never going to work, but it's going to be in the comments. I believe the information for the video will have everyone's Twitter handles and other important information there. Thank you all for coming and speaking. To all of you in the audience, thank you for watching and listening. I hope you have a great DragonCon goes virtual this year. And I hope to see you all also in 2021. Stay healthy.